Hey everybody, welcome to your chemistry homework. Tonight we're learning about limiting reagents and excess reagents. Here we go. First thing is limiting reagents. And the first thing you know is the word reagent. A reagent is really a reactant. They are synonyms. They mean exactly the same thing. Don't let that fool you. A limiting reagent or reactant, what it does is it limits or determines the amount of product that can be formed in a reaction. For example, it's a food example. If we have 4 whole boxes of graham crackers and only 1 marshmallow, the number of marshmallows we have limits the amount of s'mores we can make. Our limiting reactant or reagent are the marshmallows, because after we make 1 s'more, we're out of marshmallows. And so we're limited to the amount of s'mores we can make by our marshmallows. Our marshmallows limits us from making more s'mores. Our excess reagents, or reactants again, refer to a quantity that is more than enough to react with a limiting reagent. In this example, our same example, we've got 4 whole boxes of graham crackers. So our graham crackers, we've got more than enough graham crackers to make 1 s'more. We could only make 1 s'more because we only had 1 marshmallow. Our marshmallows limited us from making more s'mores. We have excess, or another way of thinking about it is leftover. We have excess or leftover graham crackers. And so that's our excess reactant or reagent. There's going to be 3 steps when we apply this to chemistry. Of course, we're going to have a balanced chemical equation. That's implied. But step number 1 is going to be, once we've got our balanced chemical equation, you'll be given amounts of 2 reactants. You're going to turn both reactants into one and only one product using our stoichiometry skills. Second, we'll choose the least amount of product formed, and the reactant that formed that least amount of product is going to be the limiting reactant. It's going to run out and prevent you from making more product. That other reactant will be the excess reactant. There's going to be more than enough of it to react with all of the limiting reagent. As a matter of fact, there's no way possible that we'll be able to use up all of the excess reactant, so there's going to be leftovers or excess of it. Third question, or third thing, the least amount of product formed is going to be the amount of product formed. In our food example, we can make a whole bunch of s'mores with 4 boxes of graham crackers, but only 1 s'more with 1 marshmallow. So the lower amount was the 1 s'more. The 1 s'more is the amount of product that we could form. That made the marshmallows our limiting reactant and our graham crackers the excess reactant. First example. So here's what a typical limiting reactant problem looks like. We've got amounts of 2 things. 2.58 grams of potassium chloride, 7.1 grams of oxygen. These are our 2 reactants. We're going to write a balanced chemical equation using those 2 reactants. You should be able to do that. And then we're going to do 2 stoichiometry problems. Those 2 stoichiometry problems are go along with our question C. How many grams of potassium chlorate will form? So, starting off, our balanced chemical equation is going to go like this. Potassium chloride is KCl. Oxygen is O2. That's a gas. KCl is a solid. They form potassium chlorate, KClO3. That's probably a solid. Yeah, you should be able to write this. This is one of our synthesis reactions. The patterns are on the back of the bottom of your polyatomic ion sheet. Take a look at it. You'll see metal chloride plus oxygen forms metal chlorate. Is this reaction balanced? No, it's not. We've got 2 oxygens over here and 3 oxygens over here. We'll need to make 6 on both sides. And then we've got 2 potassiums over here. We'll need 2 potassiums over there. All right, so now we've got a balanced chemical equation. We're ready to do 2 stoichiometry problems. 2.58 grams. Potassium chloride's KCl. 3-step problem. 1 step, 2 steps, 3 steps to get to our grams of potassium chlorate. So, first step, grams into moles, because that's all we can ever do with grams is turn it into moles. Grams of KCl to 1 mole of KCl. Adding up potassium and chlorine from the periodic table gives us 74.55 grams. Next step, moles of KCl is going to be turned into moles of KClO3 using our balanced chemical equation. We've got a 2 right there. And then we'll have 2 moles KClO3 on the top. Alright, now that we have moles of KClO3, we can turn them into grams of KClO3 using our periodic table again. So 122.55 grams KClO3. Where did I get 122.55, you ask? Well, I added up potassium from the periodic table, which is 39.10, plus chlorine from the periodic table, which is 35.45, and 3 oxygens at 16 to get my 122.55. Alright, so I've got some math to do. 2.58 divided by 74.55 times 2 divided by 2 times 122.55 gives me a final answer of 4.24 grams of KClO3. Second problem. I'm going to use my other starting material, which is 7.1 grams of oxygen, and do a second 3-step problem. You're going to find that it's not really a full second 3-step problem. It's really only half a second 3-step problem, because the ending part of this problem is going to be exactly the same as the ending part of the previous problem, because we're turning both of these reactants into the same product, KClO3. So, step 1, 32 grams of oxygen in 1 mole. Where did I get that from? The periodic table. And the periodic table always gives me only 1 mole. Second step, 3 moles of oxygen go to 2 moles of potassium chlorate. I get those numbers, again, from my balanced chemical equation. 2 on the potassium chlorate, 3 on the oxygen. Third step, I turn my moles of potassium chlorate into grams of potassium chlorate, and that's 122.55 grams KClO3 in 1 mole KClO3. I put the second half of both of these equations in red to point out to you that they're exactly the same. So check out the top of the middle parentheses is the same on both problems, and the last parentheses is the same on both problems, because we're converting both to the same product, the KClO3. Once I do the math on the second problem, I get 18.1 grams of KClO3. And now comes the hard part. The hard part is interpreting your results. So your results, now we need to know what these numbers mean. Here's what it means. 2.58 grams of potassium chloride will make 4.24 grams of potassium chlorate. Or if we start with 7.1 grams of oxygen, we can make 18.1 grams of potassium chlorate. So which one can we do? Which one can we do? Well, either we could make 4.24 grams of product, or we could make 18.1 grams of product. The right answer, we can make 4.24 grams of product. 4.24 grams of potassium chlorate is the answer to letter C. Why? Because once we've made 4.24 grams of potassium chlorate, we will run out of potassium chloride. That makes potassium chloride our limiting reagent. And oxygen will be our excess reagent. Why? Because we can never make 18.1 grams of potassium chlorate. This math problem says if we have 7.1 grams of oxygen, we can make 18.1 grams. But here's the thing. After we make the 4.24 grams, we run out of the second reactant. We run out of KCl. Once we're out of KCl, we're not making any more product. So our production stops at 4.24 grams because that's when we run out of our limiting reactant, and that makes oxygen our excess reactant. All right, let's do it again. Second example. Pause right now and try this out, and you're back. So magnesium chloride and lithium are going to react. Magnesium chloride is MgCl2 after we swap and drop. It'll be aqueous because you already figured out this is a single replacement reaction. Lithium's a solid. Magnesium gets kicked to the curb because lithium is higher on the activity series. Lithium hooks up with chloride and will be aqueous. Is this reaction balanced? No, it's not. So we'll need a 2 here and a 2 there. Now it is. Doing the math, we start with our 12.1 grams magnesium chloride, MgCl2, and our 5.58 grams of lithium. 2 3-step problems. Here we go. And we're turning both reactants into the same product. Which product are we interested in? Well, that is given in question C, right here, magnesium, because it says how many grams of magnesium will form. So, looking at the first problem, setting it up, we've got grams of magnesium chloride. We can only ever turn grams into moles, so 1 mole magnesium chloride has 95.21 grams in it. Second step, mole ratio, 1 mole MgCl2 has 1 mole Mg. And from the periodic table, 1 mole of Mg has 24.31 grams. For a final answer, once we calculate this all out, we get 3.08 grams magnesium as our answer. Second problem. We're going to have the same second half. We know how this goes now. 1 mole of Mg, 24.31 grams of Mg. Oh my gosh, I didn't label something. And 1 mole of Mg. First half of the problem, 6.94 grams from the periodic table in 1 mole. And from the balanced chemical equation, 2 moles of lithium in 1 mole of magnesium. Once we do this calculation, we've got 5.58 divided by 6.94 divided by 2 times 24.31 gives us 9.77 grams of magnesium. Now the analysis comes. So the analysis, what we're going to do is look at our 2 ending materials. We could make 3.08 grams. We could make 3.08 grams of magnesium, or we could make 9.77 grams of magnesium. Which one can we make? Well, we can make 3.08 grams of magnesium. Why? Because once we've made 3.08 grams of magnesium, we will run out of magnesium chloride, our limiting reactant. So MgCl2 is our limiting reactant. We will have excess, we will have leftover lithium, because really we could make 9.77 grams of magnesium with our 5.58 grams of lithium. We can't really make 9.77 grams of magnesium though, because once we've made 3.08 grams, we run out of the other reactant. We can't keep on going once we run out of the other reactant, so we're going to have leftover lithium. And there's example 2. One more example. Try it out on your paper, and now I'm going to do it. So, on this reaction, we're going to have copper sulfate, which is CuSO4. That'll be aqueous, added to K3PO4, also aqueous, making K2SO4. Once we swap and drop, we would need to check our solubility rules on that one. Or Cu3PO4, copper 2 phosphate. And we'll check our solubility rules. Once we check our solubility rules, we find rule number 6, all phosphates are insoluble. Here's our precipitate. This one's aqueous. Is this reaction balanced? No, it's not. So we've got 2 phosphates. We'll need 2 phosphates. We've got, what do we have? 3 coppers, so we need 3 coppers, and 3 sulfates, so 3 sulfates. Is it balanced now? 3 coppers, 3 coppers, 3 sulfates, 3 sulfates, 6 potassium, 6 potassium, 2 phosphate, 2 phosphate. Done. Here we go. We're going to do 2 stoichiometry problems. 25.0 grams copper 2 sulfate, CuSO4, and 25.0 grams K3PO4. 1 step, 2 steps, 3 steps. 1 step, 2 steps, 3 steps. Alright, so first problem. We've got 1 mole copper 2 sulfate over 159.62 grams copper 2 sulfate. On the bottom, we need to cross-cancel moles of copper 2 sulfate, so 3 moles CuSO4, and we're turning that into moles of precipitate, which is 1 mole Cu3PO4 2. Last parentheses, 1 mole Cu3PO4 2 gives us 380.59 grams Cu3PO4 2. Running out of room. Sorry about that. We do our math and we end up at the end, we've got 25 divided by 159.62 times 1 divided by 3 times 380.59 gives us 19.9 grams of Cu3PO4 2. On the bottom, the third part's going to be the same. So 380.59 grams Cu3PO4 2 and 1 mole on the bottom. On the top, mole ratio Cu3PO4 2. And on the bottom will be our reactant, K3PO4. And we've got 2 moles. K3PO4. How many grams? 212.27 grams. And one more on top. For a final answer of 22.4 grams, K3PO4. All right, analysis time. Here we go. So here's our two choices. We could make 19.9 grams of copper 2 phosphate, or we could make 22.4 grams of copper 2 phosphate. Which one will it be? It will be 19.9 grams. Why? Because after we make 19.9 grams of Cu3PO4, we run out of copper 2 sulfate, because that's the one that goes with 19.9 grams. So copper 2 sulfate is going to be our limiting reagent, and potassium phosphate is going to be excess. Why? Because we can never make 22.4 grams of potassium phosphate, which is shown right here. Did I write something wrong? No, I just wrote K instead of Cu right here. Sorry. All right. I wrote the wrong thing. Cu3PO4, K3. PO4 2. Oh, that's a big mistake. Sorry about that. Let me fix it in black. So this should be Cu3 PO4 2. Sorry for that initial mistake. Hope that didn't confuse you too much. In the end, what you need to know is what these numbers mean. So let's go over that one last time, and then the notes will be over. So getting out my pink highlighter, I've got what this math means down here. 25 grams of copper 2 sulfate will produce 19.9 grams of copper 2 phosphate. 25 grams of potassium phosphate will produce 22.4 grams of copper 2 phosphate. So these are choices. It's not additive, it's just choices. Either I could make 19.9 grams of product, or I could make 22.4 grams of product. How you need to think about it, you can only make the smaller amount, because once the smaller amount is formed, you run out of the limiting reactant. So I can only make 19.9 grams of copper 2 phosphate, because after that is made, I run out of copper 2 sulfate. I will never make 22.4 grams of copper 2 phosphate, because I'll run out of copper 2 sulfate before I can make that much. So our K3PO4 will never get all used up. We'll have leftover of it. All right, that's it. Bring your questions to me on Monday. Good luck.